How does light absorption happen? Imagine shining a flashlight on a glass of water. Have you ever wondered what makes some light vanish or change when it hits different objects? That's all about how light absorption works. Light is made up of tiny particles called photons, which are like little packets of energy zooming through space. When these photons bump into matter, like atoms or molecules, something interesting happens. The photons can transfer their energy to the electrons inside these atoms or molecules. Electrons are tiny particles that orbit the nucleus of an atom, and they exist at specific energy levels. Think of these levels like steps on a ladder. When a photon hits an electron, if the energy of that photon matches the energy difference between two of these steps, the electron jumps up to a higher level. This jump is called an electronic transition. Once the electron absorbs the photon's energy, it can start vibrating or moving around more vigorously. This extra energy doesn't just stay with the electron. It often turns into heat, which is why objects warm up when they absorb sunlight. The original light energy is no longer visible because it's been transformed inside the material. Instead of bouncing off or passing through, the light's energy has been taken in by the material. Different materials absorb different kinds of light, or wavelengths. For example, the color green in leaves comes from chlorophyll, which absorbs blue and red light very well but reflects green light. That's why leaves look green to us. The way a material absorbs light depends on its atomic and molecular structure. Some substances absorb specific wavelengths because their electrons or molecules vibrate at certain natural frequencies. It's similar to how a tuning fork vibrates at a specific pitch when struck. In molecules, absorption can also involve changes in how the molecules rotate or vibrate, not just electrons jumping between energy levels. That's why different substances absorb light in unique patterns, which scientists use in techniques like spectroscopy to identify materials. In everyday life, light absorption explains why the sky looks blue during the day, why sunsets turn red, and why some materials heat up quickly in sunlight. Solar panels work because they absorb sunlight and turn it into electrical energy. So, every time you see a color or feel warmth from the sun, it's all thanks to the process of light absorption happening at a tiny atomic level.